Welcome to the next video. In this video we are going to start with the relative permittivity and dielectric constant. We are very much familiar with this equation that force between the two charges when they are kept at rest position, then this force is that much, and that is been explained by the scientist named Coulomb. Now if the medium changes, that means let us consider that the two charges are kept in contact with each other. Both the charges are at rest position, but these charges are kept in vacuum. The force between them will be different as compared to when the two charges are kept in contact with each other in different medium. Let us consider the another medium is water. Then if the two charges kept in contact with each other in the water medium, then there will be a different force, even though both the charges are of same magnitude kept in contact with each other. That means if the medium changes, then it affects the force between the charges. So medium affects the force between the charges. This is something which is related to that. Now you will have to remember this, that if charges are placed in vacuum, then value of k will be equals to 1 upon 4 pi epsilon 0, and this has been calculated by Coulomb, that particular value where epsilon 0 is the permittivity of a free space. But if the charges are placed in a medium, that medium may be different, let's take an water medium, oil medium or any medium, then the value of k will be equals to 1 upon 4 pi epsilon, where epsilon will be permittivity of that particular medium. So now we will quickly review that if the two charges are placed in vacuum, then force between them will be different as compared to if the same two charges are kept in a different medium. So these are two equations. Hence in vacuum, Coulomb's law can be expressed as this, and in medium, Coulomb's law can be expressed like this. Now here are the two equations. First equation is written like this, that force between the two charges when they are placed in vacuum, so F vacuum, and when the two charges are placed in a medium, let's take a water medium, so when water medium is used, the force between the charges is F medium equals to 1 upon 4 pi epsilon 0 q1 into q2 divided by r square, where epsilon is the permittivity of the water medium. So we got two equations. First, force between the two charges in vacuum, and second, force between the two charges in water medium. So let's divide these two equations. We can write force first equation divided by second equation. We will get this equation. Just a mathematical calculation. It's very easy to understand that the denominator goes up. We will get this equation. 4 pi epsilon 4 pi gets cut, r square get cut, q1 into q2, we will get final term epsilon divided by epsilon 0. This means epsilon is the permittivity of a water medium and divided by permittivity of a free space. I'm just taking an example of water medium, that may be a different medium. So epsilon divided by epsilon 0, what does that shows? It shows that the permittivity of the medium with respect to permittivity of a free space, or you can remember like this, it is the ratio of permittivity of a medium to the permittivity of free space. This ratio is called relative permittivity. So if you have to remember what is relative permittivity is the ratio of permittivity of a medium to the permittivity of a free space. This quantity is a dimensionless quantity because it's the ratio of same quantities. So if you have to derive what is relative permittivity, then you can remember this equation: epsilon divided by epsilon 0, where epsilon is permittivity of a particular medium divided by epsilon 0 is permittivity of a free space or vacuum. Now we will come to definition of a unit charge. Consider the two charges Q1 and Q2, both having strength of 1 coulomb, kept at a distance of 1 meter from each other in vacuum. So the force between them can be written like this through Coulomb's formula, and the value of 1 upon 4 pi epsilon 0 is 9 into 10 raised to 9. That is derived experimentally. You just have to remember 9 into 10 raised to 9. So the unit charge is the amount of charge when placed at a distance of 1 meter from another charge of same magnitude in vacuum experiences a force of 9 into 10 raised to 9 Newton. That is called as a unit charge. Here it is explained the convergence. 1 microcoulomb, micro has power 10 raised to minus 6, that is 1 into 10 raised to minus 6 coulomb. 1 nanocoulomb, nano is 10 raised to minus 9 power, and 1 picocoulomb, pico is 10 raised to minus 12. You might be aware with the powers that you might have studied in 9th or 10th standard, that the conversion factors like femto, which has 10 raised to minus 15 power, pico, nano, femto, pico, nano, micro, milli, centi, deci, kilo, mega and giga and tetra. These are the conversion factors. So here it is explained just 3 which is required in this chapter. Micro 10 raised to minus 6, nano 10 raised to minus 9 and pico is 10 raised to minus 12. Now we have to define Coulomb's law in vector form. Consider the two charges plus Q1 charge is at position A and another plus Q2 charge is at position B. They are separated by a distance r. So force on charge Q1 is due to charge Q2, and force charge Q2 also experiences a force. Why it experiences force? Because of charge Q1. Now since for our convenience we have taken both the charges are positive, Q1 experiences a force in this direction and Q2 experiences a force in this direction. Now why Q1 experiencing a force is because of Q2, and why Q2 experiencing a force? Because of Q1. So force on Q1, why on Q1? Due to Q2. So force on Q1 due to charge Q2 can be written like this, where Coulomb's law 1 upon 4 pi epsilon 0 Q1 into Q2 upon r square. What R21 cap defines? It defines that force is from second charge to the first charge. R21 is a unit vector which is directed from second charge to first charge. Similarly, force on charge Q2, why? Because of the first charge. Because of the first charge can be written like force on charge 2 due to charge 1 is equals to 1 upon 4 pi epsilon 0 Q1 into Q2 upon r square. From where? That is from first charge to second charge, where R12 is a unit vector which is directed from first charge to second charge, which is directed from first charge to second charge. So I think that notations are clear to you, that F12 defines force on charge 1 due to charge 2, and F21 defines force on charge 2 due to charge 1. R12 defines unit vector from 1 to 2, and R21 defines unit vector from 2 to 1. If we compare these two equations, this and this, if we compare these two equations, we will find that R12 is exactly equals to minus of R21. Therefore F12 is equals to minus of F21. Since both the charges experiences the same amount of force, only the difference is that they are directed opposite. One is in this direction, one is in this direction. Only the difference is that they have opposite direction, but the magnitude is same. That means they form action and reaction pair. This is the Coulomb's law in vector form. Thanks for watching the video. We will come with the another topic into the next video. Thank you.